Well, thank you for joining us during lunch. My name is Ben Riga. I am a platform advisor on the Windows Azure platform evangelism team. This session is actually called Lessons Learned, Building Multi-Tenant Applications on the Windows Azure platform. It's kind of a mouthful. This whole series, we're doing 4 of these, is kind of new for PDC. We know that when you come to PDC, you come to listen to Microsoft employees. But we felt that with the Windows Azure platform, there were so many interesting solutions that were being built by partners. And since Azure is so new, we thought it made sense to actually get some partners on stage to share some of the lessons that they've learned as they built out their applications. And so I'm actually going to spend maybe a minute or 2 on stage, and the rest of that time I'm going to pass over to partners. On stage with me will be Phil Calvin, who's the CTO for SiteMasher Corporation, and then also Stephen Friedel, who is the chief architect for Quark Inc. And they're going to talk about 2 solutions that they've built on Windows Azure and that actually went live. Both of them went live earlier today. Did I get that right? Yeah, right. Awesome. Quick note, yesterday when we did our tech check, Phil plugged in his laptop and it was working great. And then we were messing around and I unplugged it and fried it. So Phil is he's using another machine. And so if you notice that he's not using Visual Studio, he's actually using Notepad to show code. Don't worry about that. That's actually my fault, and I apologize for that about 100 times. Sorry, Phil.
I actually use Visual Notepad.
OK, so like I said, I'm just going to spend a second on stage. The one thing I did want to do is set some context for the session. One of the things when you talk to different people about multi-tenancy, you can get into a debate as to what multi-tenancy means. It does mean different things for different people. I don't really want to have that debate today, but just for the purposes of today's session, when we talk about multi-tenancy, we're talking about a single instance of software that is serving multiple client organizations or tenants. This is, I actually stole this directly off Wikipedia just as a reference point. It's different from what I refer to as multi-instance, which means where you're running separate software pieces for separate tenants, even if they're running on the same hardware. So here we're talking about single software supporting multiple tenants. It's your typical SaaS model when you look at various SaaS systems, whether that's Salesforce, for instance, or our own dynamic CRM. There's many different approaches to it. The one thing that you'll see when you talk about SaaS is that there are different approaches to data isolation. When you're talking about single instance of software running on a server that's supporting multiple client organizations, you have to think about how you're going to share that software because you have data that in theory could be shared as well. And so you want to definitely isolate your data, and there's different ways to do that by having separate or shared databases and separate or shared schemas. And so obviously Stephen and Phil are going to talk about some of those things. And so with that, I'm going to welcome Phil Calvin, who is the CTO for SiteMasher Corporation. He's going to talk about their solution that they've built on Azure.
Thanks a lot. Thanks a lot. Like Ben said, my name is Phil Calvin. I'm the CTO and founder of SiteMasher. SiteMasher is a website platform infrastructure, and so that's a bit of a word. We do websites development, publishing, managing online. Best way to kind of describe what we do is we show a couple of sites that are built using our system. Now, anytime you hear about websites online, what you think about is my website on GoDaddy, click a few buttons, all that kind of stuff. That's not what SiteMasher is about. SiteMasher is about building interactive, highly customized, pixel-perfect designs. Doing it all online. This is one of our customers. This is live. This is a heli skiing company. They want to make you want to go heli skiing. That's their entire point in this site. Another one of our customers, I'll just close that. Another one of our customers is General Motors Place, and they want to show you the coming events. They want to allow you to register with them, all that kind of stuff. Click out of that. You can go to various concerts and so on and so forth. Of course, our own site, of course, runs on SiteMasher and has been running on for quite some time. I'm not going to spend a lot of time on the demo, but again, the whole point is to create highly interactive sites and very, very much tied into it. So this is our environment. What you're seeing here is our development environment. The development environment is basically an IDE in the cloud. You can create sites, you can publish it. It's got version control, access control, content management, everything built into it. At the same time, you can also build custom database schemas. You can build custom and interactive systems. I'll just show a very quick, creating a form in our system. I'm just going to create a very quick site. So go ahead and the site's all created. This is all running on Azure, by the way. I wanted to create a form on this page. I simply drag it over to the page. And what this does is it says, okay, I'm going to create this new form. As soon as I click OK here, we're going from Windows Azure over to SQL Azure. We're creating the database, the custom table on the database. And as I'm dragging fields onto this form, what I'm doing is I'm actually not only creating the user interface elements, but also the custom schema behind the scenes. And so that's just a very quick flavor of what SiteMesher does, and then I'll kind of walk through our presentation on multi-tenancy. So this is just a little bit of background on us. I started the initial development of this idea in 2006. We've been running live on our private proprietary Windows Server cloud since 2008. Systems basically ASP.NET, C#, Server 2008, SQL 2008. And we basically have launching our live version on Azure today. And the Azure team's just been tremendous helping us over the last few months. The whole system's about 1 million lines of code or so, give or take. We got the core of it running on Azure in about a week, which is kind of an interesting data point. It's, as Ben talked about, there's different multi-tenancy models. The way we look at ourselves is we're a shared everything model. We share data, we share web, and there's actually 2 different axes on our model. We have a service provider model where you can have a custom branded look if you're a service provider, say a web design company, as well as individual sites. And so those are 2 different axes. And you can give it a shot today. You can register and try it out on SiteMasher on Azure.com. This is very much a developer picture, but basically it kind of talks about our deployment model, just reinforcing what Ben was talking about. Our website infrastructure lives on top of SQL Azure and Windows Azure. Our individual service provider tenants live on top of that. And just above that is the custom websites. And this all lives on a single software platform and a single software deployment. So just talk a little bit about, very high level of our architecture. And our system is built, it's very Ajax based on the client. So there's no Flash plugins or anything like that kind of stuff. It's basically, we use JSON back and forth. The entire system revolves around the same model. There's a HTTP request in, whether that's for a page request or an asset request, or even I've added a new field to the form. It goes into the application, the Azure application, which is a web role. We use memcached, which we'll talk a little bit more down the road in this slide, for caching, which is something that's very important in our worker role. And then we use multiple instances of SQL database servers as we move along. At a very high level, this is basically, the sequence of events that happens on every request that comes into our system. First thing that happens, and this is all happening in our web role in our C# code. First thing we do is we determine the current site and the service provider. That may come from the URL. That may, if you're entering the site anonymously, it may come from the current session, so on and so forth. We then determine basically the SQL connections that we're going to need in order to process that request. Because we can basically share data all over the place, and we have a partitioning model in SQL Azure that basically allows us to get components from our system from anywhere. We need to get connection strings for both our content, whether those be objects on the page, database tables, as well as the membership provider, which is, when you log in, we want to know what credential store you're going after, and so on and so forth. We check that you have access to do that particular request, depending on what credentials you provided, or whether it's anonymous, and then we go about doing the particular request. So from our viewpoint, and multi-tenancy it means a lot of different things to a lot of people, but from our viewpoint, we really focus on providing a design environment for front-end user experience designers. So we can't have service provider or site-specific features that live on our web servers. So I can't say to a designer, you have to have this markup, and you have to have this div at the beginning or right after the body tag. That all has to be generated dynamically. Because if we put too many divs in the wrong place, web designers, they care very deeply about the HTML markup. And so if you're going to be successful doing what we're trying to do, you have to make sure you give them 100% control over the markup. So we built this around this notion of pageless web servers, which is about the best way you can describe it. So we've got an ASP.NET application that doesn't actually serve up web pages, and it interacts with our C# code to build the ASP.NET components and the markup components dynamically based on whatever the request happens to do. At the same time, there's a series of web servers or web services on those on our environment that the design studio uses. And so, the last part's pretty important, is any request for any site or any service provider can happen at any time. And that's sort of a flavor of multi-tenancy. So, as you get into online stuff, especially when you're dealing with an online cloud system like SQL Azure and Windows Azure, your caching architecture is critical for performance and how you deal with that. We were going to dig into more code, but my notebook disappeared, as Ben said. And so I'll go through. So basically, the architecture of SiteMaster, we took a look at, what does a page look like when you're trying to serve up a complicated thing? And there's a bunch of things. You've got CSS, style sheet. Maybe you got connection strings. You've got other things. You've got SQL, whatever. So we basically made what we call a self-similar component architecture that allows you to traverse up and down the system, whether that's dealing with sites, JavaScript events, content, database tables, anything like that, even external data sources if you want to, say, consume some data from like a third-party REST service or so on and so forth. So as a result, our system has lots and lots and lots of independent blobs that are related to each other but can be managed independently. And they're demand loaded in as they get acquired or as they get needed. So this is where we switch to Visual Notepad. Let me go over here. Okay, so the first thing we taught, and Visual Notepad, everybody like that? Everybody's familiar with, and I just copied some stuff over here. Everybody's familiar with membership providers and SQL providers and ASP.NET. What we did is we had basically made the membership providers multi-tenant aware. And it's reasonably simple by basically overriding two things. There's the application name and the connection string. And the application name basically comes from a number of different places depending on the context you're in. In our case, the first thing could be the service provider. An individual site could have its own members area. That would have its own another application name and another connection string. And so we basically walk through these, override these things. So as a result, we can use the .NET membership providers natively in our application, as well as profile and roles providers. Switch over to another version to do the property web service. Again, Visual Notepad. So basically, this is a web service that comes in, and we have utility functions in some of our base classes that do things like, do we have a current site? And that walks through the process of, is there a site available? Do we have either a session-based authentication, or do we figure it out from the URL? Is the user authenticated to be in a development environment on that site? And then we can go in and find our individual component that we want to deal with, and then we actually update the property. And then when you go into the property, and this is a generic part of our core system, we say what property we're going to actually updating using reflection, and we come in and go ahead and update that property once the access check is done. And so this sequence of events happens over and over. There's code underneath there that talks about to make sure it's HTML encoded and so on and so forth. I'll switch back to the PowerPoint. I was going to do a longer one, but of course, Notepad doesn't not conducive to that. So basically, the way we look at our system, it's there's minimal component access on any request, whether it's changing a style sheet, adding a new form tag, adding a new form database, or even rendering a page. So we wanted to make sure that we had sort of an order n type of an algorithm where it's every time you come in, you get exactly what you need and no more. You don't need to bring in the whole site and all its associated baggage in order to render a form or to update a style sheet property. So this demand load of components is super important from our viewpoint. We, putting the development environment in the cloud, as you click on an item in the page, we make a web service request in order to update the right-hand side properties, the style sheet, and some other components. So those web services, if you think about an application that you're using, it's a local desktop application. If it takes 500, 600 milliseconds to do every one, then you're going to need to make sure that application speeds up. So we have in our application, we have some rules of thumb on development. We don't want individual web service call to last more than 150 milliseconds, right, in a worst case basis. And so that combined with maybe a 50 millisecond overhead in the browser and hopefully under 70 milliseconds from the browser to the web server, that gives you a reasonable response time from an interactive application viewpoint. If we have a web service that's going to take longer than that, we actually change the design of it. So we say, get as much information you want, then release the browser content back and get a new system up and running. When you're dealing with SQL Azure, especially cloud-based deployment, and Steve, that you'll meet in a second, had a great comment yesterday, is that you're spoiled by SQL Express and SQL Server running locally. Put some distance between yourself as a web server and your development environment and your SQL Server. Get a SQL Azure instance, put all your data out there. If you're not yet running on SQL Azure, get a SQL Server instance, run it out in the cloud somewhere, even another remote data center. Put some latency between the two of them and profile your application. You'll find out an amazing amount of bottlenecks in your system that'll get exposed as soon as you move into the cloud. A couple quick things on lessons learned. There's an API, very useful, single tenant deployment, HTTP runtime.cache. It's great for caching. There should be a compile switch to be able to make that into a compile error. Because if you use that in a multi-tenant deployment, especially in a freely load balanced environment, you will run into bugs. You will run into things you can't track down. I can't count the number of times that something was wrong with a cached object getting out of date. And as you're dealing with a high performance, low latency application, caching becomes extremely important. If you want to deal with scaling, if you want to deal with something like that, you have to think about your caching architecture. So this particular thing, we should figure out a way to put obsolete on it. I'll talk to Ben about that. Or something, not obsolete, but just warning. Don't develop against a local SQL server on your local box. You will, as Steve will talk about, you'll get shielded from issues that will come up as soon as you deploy to the cloud. It's probably the biggest thing that you'll find. And the last one, which is again relating to the first one, is test and debug extensively under freely load balanced environments. They are completely different than your local environment running the local cloud or even just IaaS running local. You'll find so many problems if you build that into your DNA of your development and your DNA of your testing. We have in our environment, we have in our development system, we have a NetScaler front-end switch, and the developers can actually point to that switch and have it point back to their boxes. So they can set up multiple systems locally and have the NetScalers servicing requests. So you're not actually going straight to your own box, even though you're debugging on your own box. And what that does, it gives you the opportunity to test and debug under a development environment that is freely load balanced and matches up to your production environment, because you do not want to try and debug a running cloud app. It's especially while customers are signing up and your CEO's wondering why. And the last point is more just one of the things you definitely learn, and it's definitely important from our viewpoint. We're a website application. Websites, you can't schedule downtime for updates. You have to build your upgrading architecture into the DNA of how you build software and how you write software. Now, Windows Azure helps tremendously on this with the upgrade domain. So you can actually upgrade in sequence, and you can make sure your system is fine while it's upgrading. That's fantastic, and that's an infrastructure that they've provided. But what you want to do is you make sure you build that up into your DNA of your system. So what does that mean? That means you can test against schemas that are old and new. Your system will run against schemas that are old and new. You can test a new version of your software against your existing running customers and find out if everything's working. And most importantly, find out if you're going to break your new customers. And at the same time, you have to make sure you don't break your running production app while you're testing against live data. And this is something that really you have to build into the DNA of both your test environment, your QA environment, and your developers. We do upgrades usually 9, 10 o'clock in the morning when we change our system. We haven't done an upgrade at midnight or 2 a.m. on a Saturday for probably a year and a half. And the reason we did that is because you'd find 2 o'clock in the morning, we'd get somebody to go in and try and do an upgrade. Something goes wrong, what do? Right? You're basically in trouble. So in our viewpoint, we do it Monday morning, Tuesday morning, 9, 10 o'clock. Usually the entire team's in, everybody's fresh, everybody's ready to go. And if something goes wrong, you have the whole team ready to help. But if you build it in your DNA, you get your upgrades become automatically and they become part of your system. And with that, I'll pass it over to Steve, who actually has a laptop, and we'll go from there.
Hi, I'm Steve Friedel, Chief Architect at Quark, and let's see, clicker. So Quark may be familiar to a number of you in the audience. Our primary product is Quark Express. We pretty much defined the desktop publishing market back in the late 80s, early 90s. We also have a line of enterprise products, Quark Publishing System, Express Server, as well as XML Author, which is a MS Word plugin for editing XML. But what I'm here to talk about today is Quark Promote, And what Quark Promote is a new service that we are offering for the SMB market. And what this service permits is it allows users to create high-quality marketing collateral from professionally designed templates. In addition, we also provide print fulfillment through a network of neighborhood printers or prints by mail. Now, the solution Promote is composed of 4 principal components. There's a content, which is hundreds of professionally designed templates that come from our design community. A website, which allows browsing of that template content. A lightweight design tool, which is a .NET application for template customization. And a set of back office services, which handle catalog management, billing, fulfillment. So let me show you very quickly the different pieces of the product. Oh. There we go. So this is the front end of the website, note the cloudapp.net. And front page, easy and professional way to promote your business. Some of our professional print partners down here, and the different types of collateral. Take a quick look at business cards. And thank goodness this is not running off of the wireless, because that would be awful. And Dentist Dr. Moeller, one of my favorites. So this is our .NET design client. This is not Dr. Moeller. This is a template from our optometry industry vertical, the look. If you're a small business, you probably already have your own color theme chosen, perhaps something like Burning Purple, Autumn Escape, Caribbean Coastliner, one of my favorites, Elegant Royal Party. So we are a design company. So you can also modify the pictures. Somebody a little less intense, perhaps. Oops. Let's take that off, drop it in on top, bump. And then buying prints. Let's go to a neighborhood printer. Okay, how many copies would I like? Let's look around 90210 because we know that is the most important zip code around here. And we'll look in a distance of 100 miles because everybody knows Southern Californians love to drive. Oops. I promise them there's some there. There we go. Denver. And big maps. So anyway, oops. What's our initial architecture look like? We have a conventional 3-tier architecture, UI tier, composed primarily of the public website, which is an ASP.NET website, our design client, which is an ASP, a .NET WPF thin client, thick client, our services layer, which is composed of a set of core services deployed as web roles on Windows Azure, and a print processor, which is a set of worker roles also deployed on Windows Azure. For our data tier, we have a couple of SQL Azure databases, one for .NET workflow persistence. We use workflow for some of our longer running processes in print fulfillment, billing, et cetera. And a database for our transaction-specific information on SQL Azure. We also use Azure Blob Storage for storing some of the media content associated with our templates. And although it's not noted here, we also use the queue storage for communicating from the web role to the worker role. And we use table storage for storing the session data on the ASP.NET website. So pretty much we're touching all the pieces. So during the discussions with our print partners for neighborhood printing, a number of them expressed great interest in white labeling Promote for their businesses. So the engineering challenge that our friends in business development gave us, and we all know how this goes, had a great meeting with the customer, they want to see a multi-tenant solution next week, was to come back quickly with something that provided extensive branding, solid data partitioning, and was cost-effective in development, QA, and hosting because, of course, there's no budget. So we examined a number of different cloud platforms, and Azure was the obvious business enabler for us. So what was the multi-tenancy model that we decided to go with? It's a bit of a hybrid multi-tenant model where we have a single instance shared set of core services that you saw in the first architecture slide. We utilize the Azure Compute Elasticity to manage loading on that. Our databases are naturally partitioned along tenant boundaries, so we utilize separate SQL Azure instances per tenant. We've got logical separation of all tenant transactional data with that type of model. We also have separate ASP.NET websites per tenant that provides maximal branding and customization on a tenant-by-tenant basis. So this is a bit of a divide the cloud in terms of the ASP.NET websites per tenant, and a grow in the cloud in terms of the single instance shared core services, multi-tenancy models. So what were the architectural considerations? Why did we do it this way? It's primarily cost-driven in multiple dimensions. No surprises there. What we really wanted to concentrate on was cost containment for ongoing development, QA, and operations management. So the single instance shared core services with a multi-instance database basically allowed us to very quickly move and implement with no changes to our database schema. Only minor changes to our core services were required, and importantly, no changes to any of the SQL statements or ORM bindings. It's a defensive design in that the risk of accidental disclosure of one tenant's data to a second tenant is very minimized in this design. They're logically separated. They're in different databases. And because of that defensive design, we really get to minimize the scope of testing for coupling between tenants. So it keeps our QA effort down as well. So the multi-instance tenant websites permit what really amounts to sort of gratuitous flexibility in branding and integration into an existing tenant's IT environment. And through past history, it's the gratuitous. When it comes to branding, when it comes to presenting your face to the world, which is what our white labeling customers are going to want to do, they want that gratuitous flexibility. Changes to one tenant website are not going to impact the others. So again, it's a QA advantage there. And also modifications to these carved off deployments, they could be handled by a separate SI or the partner's IT staff themselves. So how do we do it? Well, speed to market was important without impacting the mainline development. And our design choice was to use a custom SOAP header to transmit the tenant ID in the set of services that we'd already created. We used contract definitions for our set of core services. So we inject a tenant ID into a custom SOAP header. We extract the tenant ID in those services. We put it in thread static storage. And then our database connection factory returns a tenant-specific SQL Azure connection based upon the tenant ID. This required about a total of 1 engineer week of effort, and the main reason for that was we had a bunch of services that we had to go through. But overall, the effort was minimal for going from a single tenant to a multi-tenant deployment. Okay, so let me switch back over so I can walk through some code. So here's our tenancy context object. You can see it's thread static. Really, it only contains 2 things: an organization ID property, get and set, and an organization name. Product landing presenter, you can see we add the tenancy injector with a WCF extension. The client-side injector, so the override here is of the iClient message inspector. So in before send request, we build the custom header for the request. And in the custom header, if we have the tenancy populated, we just, if it's not populated, return. Otherwise, we add to the header the tenancy context. And then here on the server side, after receive request, so this is an override of iMessage dispatch, iDispatch message inspector. We look for the custom SOAP header. If we don't find it, we plow ahead. And so otherwise parse it out, put it into the context, and away we go. And basically in the configuration, do I have the config files here? Yeah. Since the configuration files are all dynamically loaded at runtime, can be changed at runtime, we just put the configuration for the organization ID for each ASP.NET website that we deploy into that config file, and the service configuration with the different connection strings goes into the services, the core services configuration file. So what does it look like now? So the multi-tenant version of Promote, again, we've got distinct Azure deployments for the different public websites, the core Promote sub website being the first one, and then different white labeling partner websites. A single deployment of shared core services, multiple web roles. We're running with, I think, 4 different web roles right now, and multiple worker roles. Again, the single workflow persistence database in SQL Azure, and then multiple SQL Azure databases based on Tenant. And again, the same blob storage. The design client remains primarily the same. So let me go back real quickly here and take us back here. And here is, again, cloudapp.net, but this is Hadron Publishing. So different style on the front, shop templates, and since they're a tenant, they don't have their print partners. And under business cards, no Dr. Moeller, so they've got a separate catalog that can be maintained as well. So what are our next steps? Right now we're using ASP.NET membership, and we want to replace that with the .NET Services Access Control. We also need to refactor some of our database code to reduce the total number of SQL select statements that we're issuing in the code. And finally, we need a solution-specific monitoring and management console for this. We're planning on using the Azure Service Management API and the new Diagnostic Monitoring APIs that have just been introduced. I've actually worked with the Service Management API. It looks really good. It's going to do what we need. So what are some of our lessons learned? The first one, designing and implementing with cutting-edge .NET frameworks pays big dividends. It made the transition to Azure very, very smooth. If you're not doing it now, start working with WCF. It's going to save you all sorts of headaches later. You need to be prepared for some SQL Azure tuning. Existing schema support is very good, but it's not complete. There are a few data types that are missing. I expect that to get better over time as well. The thing to keep in mind is that SQL Azure is a shared hosted database environment, so it's got slightly different performance profiles than the standard SQL Server. So you need to expect higher latency per database operation. So what we found, and I think Phil saw sort of the same thing, is that some of the slowness in your app when you cut over and point at SQL Server, or SQL Azure, SQL Azure is slow. Well, part of that slowness may well be the fact that you're issuing too many queries, that could be packaged up and get one data set back instead of having, 100 data sets returned or something like that. So you're going to want to profile your code, and you're going to want to make sure that you're not operating with a local SQL Server instance, because it's going to be deceptive when you're doing your development and performance tuning. And finally, the tooling is still maturing, so you can expect to have a lot of trace logging in your app. That's pretty much the main way that you'll have to debug in the cloud, whereas the local app fabric will get you most of the way there. You can set breakpoints and all that good stuff, but once you're in the cloud, you're pretty much back to looking through trace logs. So in conclusion, we found Azure to be an excellent fit economically and operationally for Quark's new service. The high availability is baked into the platform, and as an architect, it's so liberating to be able to focus on our services, focus on providing those services, and not have to sweat every line of code for what's going to happen if this service drops down, or what happens if that file system isn't available or that database isn't out there. Our initial port to the Azure environment required only about 8 engineer weeks. Platforming and tooling maturity will drive that effort down. I would bet if we did it again starting right now with the current set of tooling out there, it'd be 2 weeks or less. The Azure platform, it's a key enabler for multi-tenancy in our application. It's inexpensive, easily provisioned database instances, the elastic compute services consumption, and easily deployed web roles for isolated tenant websites was basically a set of features that came together that allowed us to very quickly move from a single tenant to a multi-tenant application with very little risk to the underlying code base. Thanks.
Okay, is my mic back on? Can you guys hear me? There we go. So we're going to take some questions. There are microphones set up in the aisles there, so if you want to line up, that would be great. In the meantime, I do want to mention, like I mentioned early on, this is the first time we're doing this sort of lessons learned, where we're actually having partners on stage giving the presentations and showing that. So please fill out your evaluation forms. Let us know in detail. I promise you people are reading every one of your comments, and we're looking at that in detail so that when we look at the next PDC, we'll take that evaluation feedback into consideration. So that was the first thing, and then the next thing is, oh right, so Channel 9, please go and learn more about all of this stuff. I've actually filmed some Channel 9 videos with both organizations, and so we'll have those posted up probably before the end of the year. And so with that, let me have both Phil and Steve are here. If you have questions, please go to the microphone. Yes, sir, go ahead.
Yeah, my question is, how do you bill your customers? So you have this multi-tenanted site, and obviously you're being billed per instance and for data usage and stuff like that. How do you charge your, what's your business model around it? How do you charge your customers? Is it on a per month or a per usage basis?
Yeah.
You want to go?
I'll go
okay.
first. We do, in our model, we sell to service providers, so web design companies or anybody that does that type of thing. We charge them per site per month, and our CFO did a bunch of metrics around what sort of expected load, average load, all that kind of stuff. And so we charge them per site per month, which is a pretty low number. And then we went up to, we sort of put some business models in front of them and said, well, if we charge you $20 a month per site and you charge $60 or $70 a month to your customer for a site, including SEO operations as an example, then everybody makes money. And we did some metrics on normal loads, small to medium-sized business sites running on Azure, scaling up, and it came down to, from our viewpoint, from a cost viewpoint, going strictly on the Azure cost side, was under $1 a site from our side.
Yeah. In our case, we're not right now hosting white labeled customers. We launched our main website today, but what our current plan is to probably end up having a flat rate for getting into the program, and then beyond that, we take a slice of transactions that go through the system. So, with Azure, part of the economics are, how low can we get that flat rate, or alternatively, how good can we make our margins versus traditional hosting?
Go ahead. Yep.
Question is from the multi-tenant perspective. So the data is isolated at the SQL databases, that I understood. We have a similar scenario where we try to isolate it by websites and even to the DLL levels by doing like a strong key naming, so that if a particular client is causing some sort of an issue, it doesn't impact the other clients. So do you have the similar scenarios?
Will you go first this time?
Since basically at our service layer back, that's all shared services, separate databases. We maintain those. Nothing gets in there that's not ours. So we don't have that problem. On the front end, part of the reason why I wanted to have the separate web roles was so that we could provide that partitioning and give the ability for somebody to put, frankly, whatever they wanted. I didn't want that front website to be a blocker to signing up a customer because they needed to do some sort of integration, let's say, to their CRM system or something like that for a customer program. So that permits us the ability to partition that off in a separate web role. And even if that web role goes and melts down, it's not going to affect the other web roles, and it's probably not going to affect the back-end services either.
And from our viewpoint, what we did is we have a data services architecture that abstracts, and you can produce your own web roles that produce either REST-based or SOAP-based services or whatever it is, and we can consume those. So you isolate it that way.
I think you're waiting over here.
Oh, this one's other area. That's a question for Phil. What did you use for caching? You mentioned they don't use the ASP. So how did you solve that?
We use Memcached.
Okay.
Yeah, it's super. And then there's a .NET client that's very specific to Azure, actually. It handles elasticity of worker roles. I will get the sample code. It's actually on Codeplex, but I'll get Ben the sample code for that. And we just put basically a bunch of search and replaces for HTTP runtime and all that to get into that area. And it was very, very fast.
My email's on the slide, so just email me and I'll send that to you. Yeah. Why don't we go over to this side? Yeah.
Are you encrypting or otherwise protecting your data from falling in the wrong hands? I mean, would you place confidential data on Azure?
I think it depends on, from our viewpoint, we have a number of different mechanisms around the data protection and the data control layer. SQL Azure has a number of ways to put the data in. This was launched a month or so ago. You have firewall configuration on the SQL Azure. You also have all the appropriate rules and permissions and access controls like you would have in a normal database. And so you can actually generate all sorts of the keys, all the access controls that you want. I personally, from my viewpoint, wouldn't have concerns with it, of the data, but there's a number of different layers, not just at the SQL Server layer, but also in your application design that you can deal with data isolation and security and all that kind of stuff. But that's a longer discussion, probably.
Yeah, we don't, for instance, in our billing modules, we don't keep credit card numbers or anything like that. We pass that all through. So, we keep names and addresses and whatnot. But, basically, as Phil said, all the security's there, auth in, auth z, you name it. It's a lot like SQL Server. So I wouldn't have, frankly, a whole lot more concern over putting anything into SQL Azure than I would to SQL Server in a hosted environment.
Yes, sir, over here.
So, Phil, on the case of Memcached, are you actually hosting this within Azure, or are you just connecting from Azure to an external Memcached service?
No, we are. I'm going to go over here because apparently I'm causing a problem. I'll be in the corner over here. We have Memcached running inside a worker role, and so we can spin those up and down, as required. And like I said, I'll get the link for the client that's on Codeplex. And the nice thing about it, a traditional Memcached client will just use a sort of an order hashing algorithm. So if you change the number of instances, you almost have to punt and reboot everything. And the nice thing about this client is it's both .NET aware. It's a native .NET client. I can't remember the name of it off the top of my head. So it handles serialized objects. So you can just fire, if you've got a custom object that's marked as serializable, you can chuck it in the cache. And it'll come out the same, which is very nice, distributed cache. But it's also got proprietary implementation for dealing with varieties of the Memcache instances, as well as specific optimizations for dealing with things like strings and ints and bools and all that kind of stuff. It's very quick, like sub 1 millisecond lookups.
Okay, excellent. So, for sake of best utilizing your resources, have you considered potentially moving that into your web roles themselves?
We'd thought about it. And there is an ongoing debate if we end up doing that. But to be honest, it's the least of our problems right now. We're extremely, and the migration over to using Memcache, and the guys in the Windows Azure team helped out tremendously. It was really easy. And just the notion of scaling up cache independently of compute is kind of a nice notion, I think. Not critical, but I kind of like the separation model. But it's so if we suddenly find ourselves really getting really loaded, we can look at either model the same.
And the last question is, so have you kicked Microsoft at all to try and get them to fully integrate Velocity into that environment?
So we'll take another question over.
I think it's outside of my ability to answer.
Yeah, I don't know if we have an answer there yet. Stay tuned. More to come.
Yeah.
I think we have time for one more question. Yeah, go ahead.
So it's a question, but two parts to it. So number one is, how do you find the support when you call the Microsoft support people for the Windows Azure? And secondly, if you found issues with a particular image or virtual hard drive or remote machine, or have them change some settings because for your code wasn't working or you wanted it a certain way. How helpful were they?
I can jump in on that. The second part, we haven't had a Windows Azure specific issue. So there hasn't been, I haven't needed to call up the guys and say, hey, this is broken, can you fix it? It's worked. There's been, as Steve said, there's been some schema related issues with SQL Azure and, like I said, tooling issues that you learn through. So the second part hasn't been at all a problem. The first part, the Windows Azure team, the folks that we've been dealing with and Ben's guys have been tremendous. I mean, their response times, even coming up to this release, that I know that, I'm working on a software project, we all work on software projects, they have no time, and the Windows team and the SQL team have been first class. They've been super responsive, helping us get running. So,
Yeah, I'll pay you later for that.
yeah, absolutely. With a new notebook.
Yeah,
Did I say that out loud?
Yeah, from our perspective, I mean, we really didn't encounter, I mean, we were early adopters. We were, doing stuff even before SQL Azure CTP1, and we started with SQL Azure CTP1, and that was probably the biggest impediment, if you will, but we worked through it just in terms of having to change scheme and whatnot. But it all worked. I mean, it pretty much worked as advertised. And in terms of getting support, it's been, spectacular thus far. We get the help that we need when we need it.
So I think we're actually over time at this point. Both Phil and Steve will be around for a little while. Maybe what we'll do is we'll go outside. If you have additional questions, come by and chat. Thanks very much. And again, if you do have comments about this format of a session, having partners on stage and so on, please fill in your forms and give us those details. I know that I personally will be looking for those comments. Thanks again for joining us.